All right, guys, so thank you for watching this review video. We are going to talk about prime factorization today. So prime factorization is something that is new to you guys this year in 6th grade. And let's take a look at what a 6th grade prime factorization question might look like and dive into that and dissect it a little bit before we move into the math. So you might be asked, what is the prime factorization of, let's say, 1,000. Why not? So when you come across prime factorization problems, it's important to have a complete understanding of what prime factorization means so that you can eliminate any answer choices that don't make sense. So let's take a look at that word prime. We know that the word prime means that a number only has 2 factors. The first factor is the number 1, and the second factor is whatever that number is. So a prime number is a non-composite number, which is not composite, and has 2 factors. One in itself. Some examples of prime numbers would be 3. We can only get to 3 by multiplying 1 times 3. There's no other way to get to 3. It has no other factor pairs. Another example might be the number 7. I can only get to 7 by multiplying 1 times 7. There's no other whole number factors that will allow me to arrive to the number 7. Another example might be the number 5, the number 2, the number 11. You get the point. I can only arrive to these numbers when I multiply the whole numbers of 1 and itself. No other way to get to it. The opposite of prime is composite. Composite numbers, there's many different, well, not many, could only be 2, but there's more than 1 factor pair and more than 1 way to get to that number. So for example, if I'm looking at the number, instead of 3, what if we looked at the number 4? I can get to 4 if I multiply 1 times 4, but I can also get to 4 if I multiply 2 times 2. So there are more than 1 factor pair. That would be a composite number. We've got 5 as prime. 6 is a number that would be composite. Why? I can multiply 1 times 6, or I can multiply 3 times 2. So there's more than 1 factor pair, more than 1 way to get to that number. Other examples of composite numbers would be 8, 10, 12, so on and so forth. So that's a little mini lesson there on prime versus composite. So since we understand what the word prime means, it only has 1 factor pair, I can use this knowledge to find that prime factorization. Now, the last thing I want to talk about in this problem before we actually get started with the math is that word factorization. What's the root word of this word, factorization? What is the root word? Factor. So we need to find the factors of this number to figure out what the prime factorization would be. So I might be able to get to the number 1,000 if I do 100 times 10, right? But that would not be the prime factorization. Why? Because I can decompose, I can break up the numbers 10, I could do 2 times 5, and the number 100, I could do 25 times 4, right? Those are not prime factors. So I want to find the totally prime factorization of 1,000. So now let's get into that. The strategy that I'm going to be using is called a factor tree. Factor tree. So it's called a factor tree because you're drawing branches off of that number to show the decomposition into its multiplied factors. So if I have 1,000, I can decompose that. Remember, decompose is the math word that means to break apart. So I can decompose 1,000 into 2 times 500. So these are my little branches, and I'm drawing the factors of the number 1,000. With the factor tree strategy, when I get to a prime number, I want to circle the prime factors. So 2 is prime, but 500 is not. Go ahead and pause the video right now and try to solve the rest of this on your own. All right, so we know that the number 500 can be decomposed into 2 times 250. And if the number's even, I always pick 2. That's just the strategy I use. And we're gonna keep going. 250 could be 2 times 125. $125 could be 4 times, or I'm sorry, scratch that. It could be 5 times 25. 5 is prime, I'm gonna circle it. 25 is composite, I'm gonna decompose it. So 25 could be 5 times 5. So now let's look at what I'm left with. I've got 2 times 2 times 2 times 5 times 5 times 5. So I could write 2 times 2 times 2 times 5 times 5 times 5. Or, I could use my knowledge about exponents to say that it is 2 to the third power times 5 to the third power. That's it. That's all there is to it. We'll do one more example. Let's say that they're asking me to find the prime factorization of 625. So I'm going to start off with what I know. And let's say that 625, I could decompose that into 25 times, let's think, I'm trying to do this without a calculator. So 25 times 4 would be 100. So 625 would be 25 times 25. Math. Then each of my 25s would be 5 times 5. So it would be 5 times 5 times 5 times 5, or 5 to the 4th power. And you can double check that if you want by saying 5 times 5 would be 25, 25 times 5 would be 125, and 125 times 5 gets you to 625.